Welcome everyone. The next topic that we are going to discuss is weighted averages. So you have seen that averages. Now we are going to discuss about weighted average. Now what is the difference here? So when we have a group of terms, that is where we apply weighted average. So let's see an example here. So you consider this particular one, this particular table, right? So it's written that there is a class 9A and 9B, and the average weight of the students in the class is given, right? 40 kg and 50 kg. We are going to calculate the average weight of the students in the 9th class, right? So there are two divisions, class A and class B. We are asked to calculate the average weight of the students in the entire 9th class. Now how will we do it? So we know that average is nothing but sum divided by number of terms. So what is the sum here? We have to calculate the total sum of the weights. So 40 into 30 plus 50 into 30 will be the total weight of the entire students in 9th class divided by the total strength of the students, which is equal to 30 plus 30. So when you add this up, we'll get 1200 plus 1500 divided by 60. So this will give you the total, average weight of the total 9th standard students. The entire 9th standard students, if you take the average weight, this is what will be the answer, which will be nothing but 2700 divided by 60, which will give you 45, right? So the average of the students of this particular class will be equal to 45 kg. But I could have also find this answer. Instead of doing all this method, I could have just took the average of 40 plus 50 by 2, right? The average of the average weight, that will also give me 45. Yes, that is also possible, but that is only applicable if the number of students in both the classrooms are same. So this method, what we did over here is what you call as weighted average. That means we are considering the weights not because the weight is involved. We are assuming this particular, the number, the items number. We are giving the weightage of these values while calculating the averages. So let us try a different question. Let's see this more clearly. So there is a class 10 and there are two divisions, class A and class B. We are asked to calculate the average of this particular value. Okay. So let's find the average of the entire students of 10th standard. Now how will we do it? Again, average is nothing but sum divided by number of terms. So total number of students will be nothing but 20 plus 40, and the total weight of the students will be obtained by applying the weighted average principle, which is nothing but 40 into 20 plus 50 into 40. So this will be the weight of the students in class 10A, and this will be the weight of the students in class 10B, and the total strength will be nothing but 60. So this will be 800 plus 2000 divided by 60, or 2800 divided by 60, which will give you 46.66 kilogram. Right? Now what happened here? Look at here. In this particular case, in the initial scenario, when the number of students were equal, the average weight of the entire two classes, these students, were actually the average of the average values, right? 40 and 50, average is 45. That is what I wrote here. But look at here, what happened when the strength of the students in the 50 kilogram category was more, the average is more tending to that particular side. So if I draw a line like this, right, where I have 40 kg and 50 kg, when the number of students is more on this side, the average is pushing towards this particular side. That is how we got this particular value, right? Now there is an interesting factor for calculating weighted average. Let's take this particular case separately. Say suppose in this particular question, if there were say 10 students over class A and 20 students over class B, what will be the average weight of the entire students? Can you calculate that? So let's apply the weighted average principle. So there are 10 students in class A, 10A, and the average weight was 40. So the total weight of the students will be nothing but 10 into 40. And there are 20 students in class 10B. The average weight of that particular class was 50 divided by the total strength. How much is the total strength? It is nothing but 30. So we have 400 plus 1000 divided by 30, which will be nothing but the same value as we got before, which is 46.66. So even though the numbers changed, there is no change in the average weight. Why is this happening? Let us try with another example. What if this value is 1 and this value is 2? There is one student in 10A and two students in 10B. What will be the average weight if both the classrooms are combined together? So what will happen? Just like here, what we have is 1 into 40 plus 2 into 50 divided by 1 plus 2. So my answer will be nothing but 40 plus 100 by 3, which will be same as 140 by 3. Again, we are getting 46.66. So the number really don't matter. It is all about the ratio, right? So let's try a question with this idea. Keep this in mind that we are not minding about the number, rather we are taking the ratio of the numbers. Let's take this particular question. 13,650 pens were sold at an average price of rupees 15 and 15,600 pens were sold at an average price of rupees 45. What is the average price of all the pens together? So I have to calculate the average price of the entire pens together. By the weighted average principle, we need to calculate the total price of the entire pens. And how will you do that? So 13,650 pens were sold at a price of 15 rupees, right? So the entire price will be 13,650 into 15 plus 1560 into how much is the price? It is 45. This will be the total price of the pens. Now divided by the total number of pens, which will be equal to 15 plus 45. Now this is going to be a very tedious calculation, which I don't, encourage you to do. Instead of doing this, I told you in the previous example, that the number really don't matter. What matters is all about the ratio. So take the ratio of these numbers, 13,650 is to 15,600. That ratio is what really matters. Now when you do the simplification, you will get the ratio as 7:8. So we can do this question now in a different manner. What we have to do is 15 times 7, that is, instead of writing this number, I am just writing 7 plus 45 times 8 divided by 7 plus 8. This calculation will give you the average price of the entire pens in the lot. So which will give you the answer as 31, which is option A. So now this calculation becomes very simple. When you do this, we don't need to do this humongous calculation to obtain the answer. So this is what we apply for weighted averages. But I have to teach you a method called as CSo method. Exactly. Do you know what is CSo? When I talk about CSo, I have this very fond memories of my childhood days where you don't really care about anything, right? But after learning this particular class, you will be more encouraged to know about this particular CSo thing. So what is this? CSo is nothing but a long bar where you have a pivot attached to the center, and there will be seats over here, right? You used to play up and down. Now let us take one such kind of CSo, and you are putting a weight of say 10 kilogram over here, okay? And you are putting a weight of 20 kilogram over here. What will happen to this? This weight will actually affect the balance of this particular CSo. It will tilt in such a way that the more weight will go to the down. So it will be looking like this now, right? The 20 kg here and the 10 kg over here. Now how will you balance this particular CSo? If I want to balance this, I need to add another weight of 10 kg over here. That is one method. If I add another 10 kg weight over here, it will balance. But is there any other way? If you want to know the other method, you should know the connection with physics here. What we have here is, we are actually applying a principle of moment, or what we call as torque. So the weight exerted over here into the distance from the pivot, if that is balanced, the CSo get balanced. So instead of adding this weight over here, let me try to adjust this particular CSo by moving the pivot in such a way that the product of the distance from the pivot to the weight and the weight actually balances. So this is what we have. So I should move this pivot in such a way that it is moving closer to the 20 kilogram weight. So if I move this closer to this particular side, so let me call this as length as say L1 and this length is L2. So according to the moment principle, 10 into L1 should be equal to 20 into L2, or L1 by L2 will be equal to 2:1. So I should move in this pivot in such a way that this length is in the ratio 2:1. Now look at this ratio, it is just the inverse of the ratio of the weight which is being placed over here, right? So when we have a CSo here, so if I am attaching 10 kg here and 20 kg here, the ratio of the weight here is 1:2. Now if you move this pivot in such a way that it moves towards this particular side, that is, if it is moving closer to the weight of the heavier side, it should be in such a way that the ratio should be 2:1. So this is how we balance this particular CSo. So we are going to apply this principle in weighted average calculation to obtain the answer more faster. So let us look at this particular question. Two groups of students wrote a test. The average score of 25 students of the first group was 120, while that of the 35 students in the second group was 126. What is the average score of both the groups? How will we calculate using CSo method? So what we do is we draw a line which represents the CSo here, and here what we need to identify is actually the average values. So the average score is given to be, first group is 120 and that of second group is 126. Now I need to consider the weights as in the weightage that we have to give. So in the first group there are 25 students and in the second group there are 35 students. We have to calculate the average score if I combine these two groups together. So what is the first step in this process? The first step is to calculate the ratio of the weights. Okay, so the ratio will be nothing but 5 is common here, so I'll get 5:7. The second step is you need to reverse this ratio, just like how we balance the pivot, right? We are just reversing the ratio, inversing the ratio, so it will become 5:7. Now the third step is you take the difference between these two averages of these two groups, which will be equal to how much? 6. Now this 6 has to be divided into how many equal parts? 12 parts. So what is one part equal to? One part will be equal to 0.5. So as we know already, average of any group of values will not be lesser than the least group, or it will not be higher than the heaviest or the largest value. So look at here, I have 126 on the higher side and 120 on the lower side. So the average of this resultant value will be 7 parts more than this or 5 parts less than this particular value. Now what is one part? One part is equal to 0.5. So what will be 7 parts? It will be 7 into 0.5, which is equal to 3.5. So plus 3.5. So 120 plus 3.5 is equal to 123.5, or you can take from the other side. So 5 parts, if 7 parts is 3.5, 5 parts will be equal to 2.5, but we should be subtracting this from the higher side. So 126 minus 2.5, which will be again equal to 123. Okay, so you can take any one, you don't need to do both. So I'll explain once again. What we did over here is we have two group of students, one with 25 and the other with 35, and the average score of the first group is 120, the average score of the second group is 126. First thing what we have to do is we need to take the ratio of these two groups, which is equal to 5:7. Then we need to inverse the ratio. It will become 7:5, just like what we did in the CSo here. Right now, in order to find the average of these groups combined, what we do is we need to take the difference between the average value, which is equal to 6, and this 6 has to be divided in the ratio 7:5 or 12 parts. So 12 parts will be equal to 6. So one part will be equal to 0.5. So hence my average will be something more than 120 or something less than 126. So how much more? 7 parts. So 7 into 0.5 is 3.5, which is equal to this particular value 123. So it's a very simple method. If you visualize this, you can do this question without even writing it down. That is the advantage. So let's see another question here. If the average mark of a student for the first 6 semesters is 70% and in the 7th semester he scores 84%, what will be his average mark for the entire 7th semester? So we are given the average mark of a particular student for the first 6 semester, then we are given the mark of that same student for the 7th semester alone, and we are asked to calculate what will be the his marks for the entire 7th semester. So we have to club these two groups together. So what I write here is, I'll draw the seesaw here. So on one side we have the marks for 6 semesters, the average is how much? 70%, and on the other side we have it for the one semester alone, the 7th semester alone, which is equal to how much percentage? 84%. Now if we combine these 2 semesters, we will get the marks that the student scored for the entire 7th semester. How will you calculate that? First of all, we need to take the ratio. The ratio is very simple here, it is 6:1. Okay, so we need to inverse this ratio, which will become 1:6. Then find the difference between these 2 marks, which is equal to 14. I have to divide this in the ratio 1:6. So 7 parts is equal to 14%. So 1 part will be equal to how much? 2%. So my entire mark for the 7th semester will be between 70% and 18%, or in another words, it will not be greater than 70. Sorry, it will not be greater than 84, or it will not be less than 70%. So what you have to do here is, right, you need to take 1 part, you need to add it up with this. So 1 part is equal to 2%. So add it with this, you will get the answer as 72%, or you subtract how many parts? 6 parts from this side and subtract from 84%. So 1 part is 2%. So 6 part will be 6 into 2, which is equal to 12%. Now when you subtract 12% from 84, you will get the same 72%. So your average marks for the entire 7th semester will be nothing but 72%, which is option A. Okay. So let's go to the last question. So this is our last question. What is given here? The average weight of 32 students in a class A is 78 and the average weight of 96 students in class B is 38. Find the combined average of both the classes. So first thing, draw the seesaw. So on one side we have class A, okay, and we have class B on the other side. The students in the class A is 32, students in class B is how much? 96. And the average weight of the students in class A is 78 and that of students in class B is 38. We have to find the average of the students combined together. So it is very obvious that the average of this combined class will be greater than 38 and lesser than 78. So first thing to do is take the ratio of these values, and we know that the ratio is nothing but 1:3. Now you inverse the ratio, it will become 3:1. The next step is take the difference between these two values, which is equal to 40. So you have to divide 40 into how many parts? 4 parts. So your 4 parts is equal to 40. So your 1 part is equal to how much? 10. So either you add 10 from this side or you subtract 30 from this side. Both will fetch you the same answer, which will be equal to 48. So your average weight of the both class together will be nothing but 48. So how simple this method is, right? It's totally by using the visualization technique, we can easily solve the question on weighted averages. Thank you so much.